Hello everyone. Today in this video, we are going to study about the independent sample t-test, how to perform an independent sample t-test for given two samples. In previous video, we have studied one sample t-test, how to compare a one sample with the population mean. Here, we are going to compare two samples, whether they have taken from the same population or not. We are going to compare the means of two populations here. So how to perform this, we are going to see in the video. Suppose you have not subscribed to our channel, kindly do that. So we'll move on to that sum. Okay, right. So now here we are going to study about the independent sample t-test. Here there are two variants we are going to study. One is called the pooled t-test. Okay, now here I'm going to show it now. Okay, 1 minute. Yeah, so this is called the pooled t-test. First one, we are going to study about the pooled t-test, right? And the next one we are going to study about the Welch. Okay, that is unpooled. We'll call it as unpooled. See, most probably this pooled t-test and unpooled t-test. Pooled t-test is alone is used most of the time. This is, see, what is the difference? We're going to see. Now, suppose I'm having a population 1 here. I'm having a population 2 here. Then what is the variance? I'm going to find out a variance for this sigma 1 square and sigma 2 square. Okay, now the variance are equal. Sigma 1 square is equal to sigma 2 square. Okay, so then what we are going to do is we are using a pooled t-test here. When they are not equal, we are going to use the unpooled variance. So we are going to see how to perform this using a pooled variance here. Okay, so first of all, we should understand what is it actually. See, whenever two samples with equal variances, okay, so samples are selected from identical population here. Okay, the population is identical, so we are going to use the pooled t-test here. Now, what is the formula we are going to use it here is t is equal to x1 bar, x2 bar divided by sp. So s suffix p, I'm going to say what is this? Now 1 by n1 plus 1 by n2. Here, what is this sp? I'm going to show it. Okay, this what is this sp? It's nothing but combined standard deviation. So we call it as combined standard deviation here. So if you're not having some memory power here, so I'm going to give you one shortcut how to remember this formula. So we are going to just write this formula in some other format so that you can use this for the particular sum to do it. Okay, so now what all these we'll just know. See, what is this x1 bar? X1 bar is the mean of the first sample. What is the x2 bar? X2 bar is the mean of the second sample. Okay, what is n1? Sample size of the first sample here. Okay, so now what will be n2? N2 sample size of the second. Okay, now what is s1? Standard deviation of the first sample. S2 is standard deviation of the second. If you calculate these things, I can do the Welch test here. Okay, it is easy for doing the unpooled here. So now, in order to do the pooled t-test, we are going to find out what is called sp separately. When I use sp, okay, now it's called a pooled t-test. Without this sp, I'm using directly. I'm going to show the formula now. Without calculating this, if I use that, it's called unpooled test. So now sp is the pooled standard deviation we are going to calculate. So this is the first step we are going to calculate in the next slide. Okay, so how to calculate this? We will do an example. We'll find it out here. Okay, now v is nothing but the degrees of freedom. It is usually n1 plus n2 minus 2, because always the degrees of freedom will be usually written as n1 minus 1 for the first sample and n2 minus 1 for the second sample, so that we can have the combined degrees of freedom as n1 plus n2 minus 2. This is important to calculate. Okay, right. So now, how to go about this, we'll see with an example. Right now, when we go for an unpooled or Welch test here, we are going to use this formula. Here you see there is no combined standard deviation. Okay, standard deviation of first group is given, standard deviation of the second group is also given. There is no combined standard deviation. So what we are going to do, this is the standard deviation of the first one, standard deviation of the second one, so which is squared inside the square. Okay, you have to note it down here. So what is it? X1 is the mean of the first sample, X2 is the mean of the second sample, N1 is the sample size, okay, of the first sample here, and N2 is the sample size of the second one, right? S1 is the standard deviation of the first sample, S2 will be the standard deviation of the second sample. Okay, now here one thing you have to notice here, your degrees of freedom is calculated using this particular formula. Okay, this is a bigger formula. You have to remember this formula: S1 square by N1 plus S2 square divided by N2, and S1 square by N1 the whole square, and S2 square divided by N2 the whole square. This is the formula for calculating the degrees of freedom here. So in this particular video, we are going to see only the pooled t-test. Okay, so we are going to study the pooled t-test. We are going to omit this unpooled t-test. We'll be doing a separate video for how to find out the unpooled t-test here. Okay, so now we'll move on for an example here for the independent sample t-test, pooled t-test. When to use this? This is what is important here. When to use this? Whenever the populations are having the equal variances. Okay, so this is from the population 1, this is from the population 2, this is the population variance of the first population, this is the population variance of the second population here. So when they are equal, we are going to use the pooled t-test. When they are not equal, we are going to use the unpooled t-test. Okay, so now imagine that we have got one sum with the equal variances. We are going to do the t-test. How to do from the step 1. Okay, so now here, say I'm going to give one example here. We can have this example here from the following data. Okay, it can be assumed that the two samples came from the normal populations with the same mean. Okay, so same means it is coming from one population. So this is sample A. I'm going to have it here. This is called the sample B here. So we are going to say that these two samples came from the same population. So how to go about this? We are going to do this in the sum. So first of all, what you have to do is, first of all, you have to frame the hypothesis here. So how to frame the hypothesis? I'm going to show it. I'm going to frame the hypothesis like this. Okay, the two samples have been taken from the same population. There is no difference between the mean. Usually we'll take the null hypothesis like this. So I can write in words like this, or I can write this as symbolic, or I can write both. Okay, so nothing wrong in that. Okay, so this is the first method of doing it. This is the second method of doing it. So whichever is easy for you, that you can do it. Okay, now mu1 equal to mu2. Mu1 will be the sample of the first one, mu2 will be sample of the second one. So we are going to take it as the equivalent one. Okay, so now, so this is what is the null hypothesis. So when you want, you can have the alternate hypothesis also, which is the opposite of the null hypothesis. So alternate hypothesis says the two samples have not been taken from same population with the same mean. So what I'm going to do is mu1 not equal to mu2. So just omit this. There is an error here. So this KGC can remove it here. Right. So now, how to do this? What is the first step in doing this? We are going to see. So now first, we are going to calculate the combined standard deviation using this particular formula. Okay, so we are going to use this combined standard deviation for this one. Okay, so now this is called combined standard deviation. Okay, so combined SD. Okay, so now I'm going to just calculate this. How to go about this is, see now, for my calculation, what I'm going to do is here, I know what is S1. Okay, so S1 is nothing but square root of, okay, sigma x minus x bar the whole square divided by n minus n1. I can have it n1 minus 1. Okay, now, so that is what is S1 square. If I have it, I am removing this square root here. Okay, so what I write is S1 square will be sigma x minus x bar the whole square divided by n1 here. Okay, I'm going to write n1 minus 1, n1 minus 1 here. Okay, so now here if I multiply by n1 minus 1, this get cancels. So instead of s1 square, I can write this alone. Okay, so I'm just modifying this formula for me to calculate. So instead of s1 square, so this formula is converted into like this for me to calculate it. Okay, so now this is easy for me. Okay, this formula, see, two methods you can do. Either you can find out s1 square separately, you can substitute it here, or you can have this particular formula converted into this one. Both are equal here. So I'm going to use this alone for my calculation here. Okay, so this alone I'm going to use it for my calculation. I'm going to finish it off here. Now we'll calculate how to calculate this. We are just finding out, see, x and y values already given here. Now, as usual, we have done it so many sums here. So I'm just moving on here. So I'm going to find out x bar first, then I'm going to find out y bar first, then I'm going to substitute here. Now, how to find out x bar? Just total these two columns here. Okay, first column we have totaled here. It comes around 121. Second one, I'm going to total it. It comes around 132. Okay, so now this is the mean. Okay, so mean I'm going to calculate x bar is equal to sigma x by n. So that's what is here. How many values are there? 1, 2, here 3, 4, and 5. Okay, so now I'm dividing it by 5. So I'm getting 25 as the mean for the first one. So I'm going to calculate for mean for the second one also. I have calculated already here. Okay, so now what I'm going to do here. Okay, this particular 24 here, 24, I'm minusing with 25 here. Similarly, 27 minus 25. Like this, I'm going to calculate for this particular column. So we have done these methods already. So what I'm going to get it here, it is 24. Okay, so now this is 24 minus 25, which gives you 1, and 27 and minus 25, 26 minus, and this is 24, 23 minus 25, which gives you 2, 25, 25, 0. So I'm going to square these here now in this column and square the y value. I'm going to calculate y minus y bar here. So what is my y bar is? So it's here I have to write 27 minus 29. Here I have to write 30 minus 29. Here I have to write 28 minus 29. Here I have to write 31 minus 29. Here I have to write 22 minus 29. Here I have to write 36 minus 29. We are going to calculate how much it is coming. So now I am getting the value here. See, minus 2, this is 1. So how we are getting it? So 27 minus 29, which gives you 2. 30 minus 29, which gives you 1. 28 minus 29, which gives you 1. 31 minus 29, 2. 22 minus 29, which gives you 7. 36 minus 29, which gives you 7. Okay, now I'm going to square these columns here. So square it and write here. Okay, 1 square, which gives you 1 here. I'm sorry. Now, okay, now I'm going to square it and write it here. 1 square is 1, 2 square is 4. Okay, so this one I'm squaring. Okay, 1 square is 1, 2 square is 4, 1 square is 1, 2 square is 4, 0 square is 0. This is completed. Now I'm going to square this column and write here. Okay, square this column and write here. So how to write here is, so 2 square, which gives you 4 here. Okay, this should be 4 here. Okay, now 1 square is 1, 1 square is 1, 2 square is 4, 7 square is 49, 7 square is 49. So I'm going to total these two columns. I'm going to substitute in this formula to find out what is my SP here. Okay, what is my SP comes here. I'm going to calculate here. Okay, so now this total comes around 10. This total comes around 108. So substitute in this formula. Okay, now x minus x bar. You know how to substitute already. We have done so many sums. Okay, so if you have not visited already, just visit and see all these sums. We have done it elaborately. How to calculate, how to substitute all these values. Okay, so now here quickly we move on how to substitute this value. Okay, sigma x minus x bar the whole square, which comes around 10 here. I'm going to substitute that value 10 here. Then now this is 108. 108 comes for y minus y bar. So 108, I'm writing it here. Okay, now what is my n1 is 5. What is my n2? N2 is 6. So what I'm going to do it, I'm subtracting minus 2. Using a small calculator, you can calculate it. Calculator is allowed for you for your exam, right? So 118 divided by 9, which gives you 13.11. So I got SP value, right? S suffix P. The combined standard deviation is 3.62. That's all. Then we are going to substitute in the main formula. Then we are coming to a conclusion. So how to do that? So what is the calculation we are going to do? This is the formula which we have got it already. We got x1 already. So what is that? 25 we finished. What is x2? We got it already. That is 29 here. Okay, so 1 by n1 plus 1 by n2. There, see x1, x2, we have taken it as y minus y bar. Just you can substitute. Okay, so x1 or x2, two values. I have taken it as x and y for clarity. So you can have it. So usually it should be like this. Now x minus x1 the whole square should be there. So x minus x2 the whole square should be. So this one we have taken it as y minus y. Okay, so now like this. For our clarity, we have taken it. So just visit the previous. Okay, I'm going to show it here. Okay, now this is what. Okay, so first one and second one we have taken it. So then we are substituting in x1 and y1 here. So we'll move on to this here. Okay, so this is what is the formula. We are going to substitute these two values here. Okay, so now 21, this is 25 and 29. Then SP, we have got it here. 1 by n1 is 1 by 5. This is 1 by 6. Then we are going to substitute minus 4 divided by 3.62. Then if you do the calculation, I am getting one value here for t. Okay, so now I'm getting a negative value. Usually I should take it as a positive value. That is the modulus value. I'm going to take it. So modulus is 1.81. This I will call it as calculated value. Okay, now t cal, I will call it as calculated value. Now from the t table, what is the degrees of freedom we are going to calculate here? Degrees of freedom is equal to n1, n2 minus 2 is equal to 5 plus 6 minus 2 is equal to 9. Okay, this is n1, this is n2. So I got the degrees of freedom is equal to 9. For this 9 degrees of freedom from the t table, I am going to find out the calculated value here. How to calculate that value? So take a t table, find out for 0.05 alpha. Okay, so now t 0.05 at 9 degrees of freedom. You have to see, we have shown already in the previous example how to calculate this t value from the table. So you can see that t value from the table, it has been given as 2.262. So we are going to compare. We have got two values. Okay, one is calculated value, one is tabulated. Okay, now this is the value 1 here, this is the value 2 here. We are going to compare this for giving a conclusion. How to do that? So now t calc, this is what is the value we have calculated. Okay, so this is what is the value we have calculated, 1.81. Now we are going for the tabulated value. Then we are going to compare these two values. Okay, how to compare this? Now if you compare, t calculated value is less than that. Okay, so now our value less than that, so we will accept it. Okay, now we should not write we accept it, so we should say we fail to reject a null hypothesis at 5% level of significance. Where from this 5% is coming? Because we are taking it as alpha as 0.05. If nothing is given, you have to take alpha is equal to 0.05. Sometimes alpha will be given as 0.01 also. If it is given, you have to take it as 1%. Alpha is given as 0.01. This will be taken as 1% level of significance. Okay, so now we are going to say we fail to reject the null hypothesis at 5% level of significance. Okay, now this confidence level will be always calculated as 1 minus alpha. You remember now 1 minus alpha that we are going to calculate is 0.05, which comes around 95%. So that we will come to the conclusion when we are writing. Okay, now inference, what we do is we conclude with 95% confidence. Where from this 95%? Because it is 5%. This is 95%. Both should be equal to 1, or else you can remember this formula. So it should be 1 minus alpha. Okay, now 1 minus alpha you should remember. Okay, now 1 minus 0.05. Okay, 1 minus 0.05. Then subtract it, you will get 0.95. So that is 95% confidence that the given sample are taken from the population with the same mean. This is how we will calculate using the two sample t-test. Okay, so in the next video, we are going to see the paired sample t-test. So thank you very much for watching this video. If you like this, kindly subscribe, share it, and have a good day.